The National Electrical Code, specifically Article 250.30 1.3, addresses the grouping of service meters. The code mandates that service meters for multiple occupancies must be grouped as closely together as practicable. This requirement serves to facilitate the inspection and maintenance of these meters. When meter bases are spread out significantly, such as over 80 yards, this grouping requirement is not met. This can lead to difficulties and increased time when performing inspections and maintenance. Moving on to securing service raceways on a roof, the preferred method is to strap them directly to the roof structure. This is achieved using metal straps or brackets. This approach ensures a secure and permanent attachment capable of withstanding wind and other environmental forces. If penetrating the roof for attachment isn't feasible, an alternative is to use a strut or angle iron along the side of the building to support the raceways. The strut should be securely attached to the building structure using appropriate fasteners. The raceways are then strapped to this strut. When addressing raceway protection after events like re-tarring a roof, carefully remove any tar from the raceways. Use a solvent or tar remover, taking care not to damage the raceways in the process. After removing the tar, seal any openings or cracks in the raceways to prevent moisture from entering. Use a sealant or caulk that is compatible with the raceway material. Given that the raceways have been exposed to tar and moisture, applying a corrosion-resistant coating is highly recommended. This coating protects them from future damage. Ensuring that raceways are properly secured and protected is crucial to prevent damage and potential electrical hazards. The goal is to maintain electrical safety and code compliance. When securing electrical components, always consult the relevant sections of the National Electrical Code. These sections include 300.4, which covers protection against physical damage, 314.17 1.2 for box fill calculations, and 310.15 for conductor ampacity. Also reference tables 310.16 and 310.17 for allowable ampacities of conductors. When installing service raceways, it's critical to ensure they are adequately supported to prevent sagging or damage. Support methods can include using appropriate clamps, straps, or hangers designed for the specific type and size of raceway being installed. The spacing between supports should comply with the NEC guidelines and the manufacturer's recommendations. For example, rigid metal conduit requires support every 10 feet, while intermediate metal conduit needs support every 10 feet as well. Electrical metallic tubing typically requires support every 10 feet. Non-metallic conduit, such as PVC, may need more frequent support, especially in warmer climates, to prevent sagging due to thermal expansion. When routing raceways across roofs, protect them from physical damage and exposure to the elements. Consider using conduit with a sunlight-resistant rating and providing additional protection where raceways are exposed to heavy foot traffic or potential impact. Also, ensure that all connections and fittings are watertight to prevent moisture from entering the system. Grounding and bonding are essential for electrical safety. The NEC mandates that all metal raceways and enclosures be properly grounded and bonded to create a low impedance path for fault current. This helps to minimize the risk of electrical shock and ensures that overcurrent protection devices operate correctly. Use grounding bushings, bonding jumpers, and other appropriate hardware to establish a reliable ground connection. The size of the grounding conductor must comply with NEC Table 250.122, which is based on the size of the overcurrent protection device. When working with multiple services in a building, it's crucial to clearly identify each service and ensure that the disconnecting means are readily accessible. The NEC requires that each service disconnecting means be marked to indicate the load it serves. This helps to prevent confusion and ensures that the correct service can be de-energized in an emergency. The location of each service disconnecting means should be clearly labeled, and a directory should be provided to identify the areas served by each service. In addition to the NEC, local codes and regulations may impose additional requirements for electrical installations. It's essential to consult with the local authority having jurisdiction to ensure compliance with all applicable codes. Local inspectors can provide valuable guidance and help to identify potential issues before they become problems. Proper planning and coordination are essential for successful electrical installations. Before starting any work, develop a detailed plan that includes the routing of raceways, the location of equipment, and the grounding and bonding requirements. Coordinate with other trades to avoid conflicts and ensure that the electrical system is properly integrated with the building's other systems. Regular inspections and maintenance are critical for ensuring the long-term reliability and safety of electrical systems. Conduct periodic inspections to identify potential problems such as loose connections, damaged raceways, or corrosive components. Perform routine maintenance such as tightening connections, cleaning equipment, and replacing worn parts. Keep detailed records of all inspections and maintenance activities. When working on electrical systems, always follow safe work practices. Energize circuits before working on them, and use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. Follow lockout/tagout procedures to prevent accidental energization of circuits. Be aware of the potential hazards associated with electrical work, and take steps to minimize the risks. The NEC is a comprehensive set of standards for electrical installations, and it's essential to stay up to date with the latest edition. The NEC is revised every 3 years to reflect changes in technology and best practices. Familiarize yourself with the changes in each edition and ensure that your work complies with the current requirements. Continuing education is essential for electrical professionals. Attend training courses, seminars, and workshops to stay abreast of new technologies, code changes, and best practices. Obtain certifications and licenses to demonstrate your knowledge and skills. Invest in your professional development to enhance your career and provide the best possible service to your clients. When dealing with electrical issues in existing buildings, it's essential to thoroughly investigate the existing conditions before starting any work. Identify any potential hazards, such as asbestos-containing materials, lead paint, or concealed wiring. Assess the condition of the existing electrical system and determine whether it's adequate to meet the current and future needs of the building. Develop a plan for upgrading or replacing any outdated or unsafe components. When making modifications to existing electrical systems, ensure that the new work is compatible with the existing system. Use compatible materials and equipment, and follow the NEC requirements for splicing and terminating conductors. Verify that the existing system has adequate capacity to support the new load, and upgrade the service or distribution equipment if necessary. Documentation is essential for electrical installations. Keep detailed records of all work performed, including drawings, specifications, and test results. Provide clear and accurate labeling of all equipment and circuits. Maintain a comprehensive electrical plan for the building and update it whenever changes are made. When troubleshooting electrical problems, use a systematic approach to identify the root cause. Start by gathering information about the problem, such as when it occurs, what symptoms are present, and what equipment is affected. Use appropriate test equipment, such as multimeters, clamp-on ammeters, and circuit tracers to measure voltage, current, and resistance. Analyze the test results to identify the source of the problem and develop a plan for repairing it. Surge protection is essential for protecting sensitive electronic equipment from damage caused by voltage surges. Install surge protective devices at the service entrance and the branch panel boards to protect the entire electrical system. Use point-of-view surge protectors to protect individual pieces of equipment. Ensure that surge protective devices are properly grounded and bonded. Power quality is an important consideration for modern electrical systems. Poor power quality can cause equipment malfunctions, data loss, and increased energy costs. Use power quality meters to monitor voltage, current, harmonics, and other parameters. Implement power quality improvement measures such as harmonic filters, voltage regulators, and uninterruptible power supplies. Energy efficiency is a growing concern for building owners and operators. Implement energy-efficient lighting, HVAC, and other electrical systems to reduce energy consumption and lower operating costs. Use energy management systems to monitor and control energy usage. Conduct regular energy audits to identify opportunities for improvement. Renewable energy sources, such as solar and wind, are becoming increasingly popular. Consider installing renewable energy systems to generate electricity on site and reduce reliance on fossil fuels. Obtain the necessary permits and approvals, and follow the NEC requirements for connecting renewable energy systems to the grid. Electric vehicle charging stations are becoming more common as electric vehicles gain popularity. Install electric vehicle charging stations at homes, workplaces, and public locations to support the adoption of electric vehicles. Follow the NEC requirements for installing electric vehicle charging equipment and ensure that the charging stations are properly grounded and protected. Smart home technology is transforming the way we live and interact with our homes. Install smart home devices such as smart lighting, thermostats, and security systems to automate and control various aspects of the home. Use a central control system to manage all of the smart home devices. Ensure that the smart home devices are properly secured and protected from cyber threats. Electrical safety is a shared responsibility. Educate building occupants about electrical safety hazards and how to prevent them. Post warning signs and labels to alert people to potential dangers. Conduct regular safety training for employees and contractors. Promote a culture of safety in the workplace. Remember to use appropriately sized conductors and overcurrent protection. The size of the conductor must be sufficient to carry the intended load, and the overcurrent protection device must be sized to protect the conductor from overload. Consult the NEC tables to determine the appropriate conductor size and overcurrent protection for each circuit. Be sure to properly terminate all conductors and make sure that the connections are tight. Loose connections can cause overheating and electrical fires. Use appropriate connectors and tools to ensure that the connections are secure. Inspect the connections regularly to ensure that they remain tight. Also, protect electrical equipment from physical damage. Install equipment in locations where it is not likely to be damaged by impact, vibration, or other hazards. Use guards, barriers, or enclosures to protect equipment from damage. Inspect equipment regularly to ensure that it is in good condition. Following these best practices, securing service raceways and grouping meters will help maintain safety, code compliance, and efficient electrical systems.